teacher, they spend a lot of money to improve. So let's take a look at what the scoring model actually measures. If we don't look at accuracy, what exactly are we looking at? All right, everyone, let's get another set of slides ready. Let's take a look together. First, let's explain a few key points. They want to assess exam ability. So how do they measure it? In a moment, you'll see a number called B. All right, B refers to what we call difficulty. You can see it here. I have a few key points to mention. First, in the entire exam, there is no such thing as partially correct. For every question, there are only two possible responses. Either you get it right or you get it wrong. It doesn't matter which option you chose incorrectly. This is very important. Okay, next, they want to measure the candidate's theta value, which is the candidate's ability. Each question has its own difficulty, called beta or B for short. All right, let's first take a look at how exactly this is done and why the cost of a single question is so high. The reason why the cost of a single question is high is because after the question is created, it's not used directly. The difficulty of the question is also not determined by the person who wrote it. Pay attention, the difficulty of a question is not determined by the question writer. So how is it determined? The question will first be included in the official exam. In the official exam, based on past experience, about 10 to 16% of the questions are test questions, which fortunately we can identify. For example, in the 31 math questions, 3 of them are test questions. All right, IRU, DI is we call IR. There used to be 12 questions in total, with 4 of them being test questions. And then in the old verbal section with 36 questions, there were 6 test questions. So proportionally, it's roughly either 10%, 16%, or 25%. Some of the questions will be test questions, but we still don't know for sure because the system doesn't specifically indicate them. Okay, all right then. We also don't know when the test questions will appear, where they'll show up, or what type of questions they are. When you're taking the exam, you have no way of knowing. So there's no need to try to guess which ones are test questions. Okay, the purpose of this is that when a question is newly designed, we don't know whether this question is actually valuable or what specific characteristics it has. So they have various people test it and then create something like this to evaluate whether a question is well designed. You can see that a well-designed question should be like this. There will be one option specifically designed to distract you, and the other 2 options are just normal incorrect choices. Of course, this is for 4 options, but there should actually be 5 options. Furthermore, the correct option has a particular feature, which is that its correlation is such that the higher a person's ability, the more likely they are to choose the correct answer. Now, there are some poorly designed questions, such as those with double answers, where people with higher ability might find both options easy to choose. Or, in cases like this, the question design is just bad, right? People with higher ability can't even see the correlation coefficient. Or sometimes it's simply a design error. The official correct answer is the first one, but actually the higher person's ability, the more likely they are to think C is the answer. It's things like this, or like here, where there's an option that no one would ever choose, so that's just a waste, right? Anyway, this is what they mean when they say they'll include these in the test to evaluate the quality of the question itself. Basically, if a question is up to standard, it passes. If not, it gets sent back for revision or is simply discarded. After all, the cost of creating each question is so high, so let's not doubt the official answers. Many students say, Dustin, I think the answer in the OG might be wrong. Or why isn't this the answer? Why isn't it A? Why is the answer D? Don't think like that when you're reviewing. Your approach should be to think about why smart people would choose D, not to insist on your own answer. Because every question that makes it into the OG or the exam has already been statistically validated. It's impossible for any individual to question it. Okay, of course, the official authorities also won't give you any legal way to challenge it. So what should your mindset be when practicing for the exam? It should be, why do highly capable people choose the correct answer rather than thinking, why isn't the answer what I thought it would be? Okay, so this approach needs to be done well. This is something I often talk about when I'm coaching or guiding students, especially those in intermediary roles. If you can adjust your mindset properly in daily practice, you can avoid a lot of unnecessary trouble. All right, thank you. Now, let's take a look. Besides checking whether a question is up to standard, there's something else we also do. This is the core of the entire scoring mechanism. Every question has a function, and we call this function the item characteristic curve. Okay, so what is special about this function? It's about people with different abilities. You can imagine this end as 200 points and the other end as 800 points. Then you can picture people from different ability groups. For a single question, many people have taken it. And of course, they answered this test question without knowing its purpose. Then it will also plot the probability that a person with a certain ability level answers correctly. For instance, among people with 200 points, 12 out of 100 answer correctly. Among people with 300 points, 15 out of 100 answer correctly. It will plot all of this as a line like this. Okay, so this line has 3 important coefficients, and these 3 coefficients will be stored in the question bank. So the question bank will look like this. It will look like this. You see? Okay, it has a method. What's in the question bank? That is, all right, the first one. What is A? Let's think about B first. B represents difficulty. It will be located around the middle at about the 50% mark, the point where the correct answer rate is 50%. Just imagine The higher person's ability, the higher the probability they will get this question right. The lower their ability, the lower the probability. So if a person's ability is right in the middle, it should be said that this refers to people who have a 50-50 chance of getting this question right or wrong. At this point, the corresponding ability level is exactly the difficulty of this question. Okay, so what is A? A is called the slope, which means the higher the slope, the more even a small difference between your ability and the difficulty will matter. Then your probability of getting it right or wrong will fluctuate more dramatically. This is the concept of discrimination. Okay, so if a small difference in ability leads to a big difference in the probability of answering correctly, that means the question has a high discrimination and is better at distinguishing people with different abilities. So what is the third one? C refers to, for a question, if you give it to the least capable person, basically letting someone answer blindly, what is the probability that they can guess it correctly? Okay, so if this value is too high, then the quality of the question isn't very good. So what should a good question be like? It should be that the higher the discrimination, the better. C refers to the probability that the least capable person, as we just mentioned, can guess the answer ideally. This probability shouldn't be too high. So for each question, there will be these three numbers, A, B, and C. Okay, all right. So how do they actually make the selection? Well, after you finish each question, they use what's called the maximum likelihood estimation method to estimate what your most probability level is after completing that question. All right, let's look at a practical example, one that's relatively easy to understand before we move on to the more complex parts. Okay, we'll also do a Python simulation later. Let's suppose that after the candidate finishes the test, they get the first question right. The system will then look at the feature function for the first question right? It will then check in the BT, for example, if you are a person with a score of 400, the probability of getting it right is 0.73. So 73% of people with a score of 400 will get it right. For people with a score of 500, it's 0.76. And for 600, it's 0.78. Since you got it right, the most likely probability is this one, right? Okay, so here there's a 73% chance that your ability is minus 0.2. A 76% chance it's this ability and a 78% chance it's this ability. For the next question, if you get it wrong, right? If you get the next question wrong, then of course, if you get it right, it'll also pick out this probability for this ability, right? The probability of getting it right is extracted, and this function is used to add them up. Okay, this way it can assess what ability level you are most likely to have, and then give you the next question based on that ability. That's how it works. Of course, if you get it wrong, it will do the opposite and extract the probability of you getting it wrong. All right. Then use this calculated probability to layer it on top of the previous probability. Okay, if anyone here understands so far, could you type a 1 for me? Good. For now, don't think about any math, just focus on the description I just gave. What it's doing is stacking all the different probabilities together. So if you get it right, you extract the probabilities of getting it right for each different ability. If you get it wrong, you extract the probabilities of getting it wrong for each different ability. And then you stack all these probabilities together. Now, you can imagine that if you get it right, your probability will look like this, right? This is the probability of getting it right. So what about the probability of getting it wrong? Because it's the opposite. It's 1 minus p. So the probability of getting it wrong will look like this. It's like this, just like blood. So as these probabilities are gradually stacked together, whether you get it right or wrong will slowly form a certain curve, forming a curve that looks like this. Each time, the highest point of this curve represents what it thinks is your most likely current ability level. Here, this is the curve formed by stacking several questions you got right. And here, this is the curve formed by stacking several questions you got wrong. So how does it choose the next question? They use a method called maximum information. That is, after each question, once it has determined your current ability, it will calculate among the remaining questions the information value for each one. Which question can give us the most information? What does maximum information mean? Let me give you an example. Have you ever played the game Ultimate Password? Out of numbers from 1 to 100, the other person has already picked a number, and your job is to guess which number it is, right? So if you make a guess, they'll tell you whether the answer is higher or lower, right? For example, if you say 30, they might tell you it's between 1 and 30. Or for example, if you say 70, maybe they'll tell you it's between 1 and 70. Now, let me ask you something. When you have no information at all at the beginning, which number should you guess to get the most information? If the range is 1 to 100 and the other person has already picked a number, but you don't know which one, and your first goal is to narrow down the range, which number should you choose to guess in order to get the maximum amount of information? Right, very good. As you can see, some students answered 50, right? That's correct. Choosing 50 immediately splits the range in half, doesn't it? This way, you get the maximum amount of information. Actually, this is the same concept. Each time, based on its latest estimated theta value, it will immediately calculate among all the remaining questions. One question doesn't always give us the maximum amount of information. And in the end, that question appears, okay, good. So it doesn't just use both, because sometimes what happens, sometimes it even refers to whether some questions have higher discrimination because the C value of the question is higher, like this. Okay, good. Actually, that's what we've covered so far. we've now reached the comprehensive conclusion of the entire scoring model explanation. Okay, so every single time is essentially about meticulously repeating this precise process. Let's thoroughly go over it once again, right? Each and every time you are presented with a new question, it will inherently know, based on your detailed answer, how to proceed. It will extract from the item characteristic curve the probability of getting each ability level right or wrong. After plugging in this probability, it will arrive at a temporary peak, that is, your most likely estimate, your current most probable ability value. What happens next? Then, based on this number, right, using this number, it will pull out all the remaining data from the question bank. It will then calculate the fit between the remaining questions in the bank A, B, and can your profile to compare them. Which question can provide us with the most information? Okay, we call this test information, all right? Then it selects that question and continues testing you. After the test, it pulls out the new probability, overlays it with the previous probability, and in the end, this function will gradually change like this. Okay, so actually, we've already explained the scoring mechanism up to the point where I stopped at the last question. The last question, for example, might be the second or third verbal question, or the 21st math question. After you finish, say, the 20th question, the final vertex represents your score. It will then convert this score into a scale score, and finally convert that scale score into a percentile for you to see. That's how it works. Now, let's talk about how we actually implement this, which will be shown on the transcript later. Let's take another look at this estimation. All right, this is based on actually, as I just mentioned, this algorithm isn't really anything new. In fact, GMAT officials have said that this algorithm wasn't invented by them. It's actually an algorithm that has been widely used in the academic field of psychometric testing for a long time. So if you search online, you'll find a bunch of papers about this. After reading a lot of them, we were able to write this ourselves. First, let's talk about what information you'll see on the score report. You'll know exactly which questions the test taker got wrong, right? For example, here we're simulating a math question. There are a total of 21 math questions, right? On the score report, how many questions does it actually show for the test taker? We'll generate a simulated question bank. And just like we saw earlier, each question in the simulated bank has options A, B, and C. As we just saw, every question has these options, A, B, and C. All right, so next, for each question, it will calculate the information. With a good amount of information, it will pull out all the A, B, and C options from the question bank to see how your current performance is and how you make your choices. You see, when we actually run it, it looks like this. Hold on, let me show you what it actually looks like when it runs. This will be easier to understand. In the program, for each question, it calculates which question has the highest information value based on your current theta value. And then it selects that question to test you. After you answer the question, whether you get it right or wrong, the system will immediately give you an updated estimate of your theta. Then, using this new theta estimate, it checks all the remaining questions in the question bank to see which one has the highest information value. It keeps running like this, question by question, until you finish the last question. The final estimate you get at the end is your final score.